So today we're talking about the explicit formula to figure out sequences. Now, previously we've been using the recursive formula, which the recursive formula is still valid. The recursive formula is how we think about sequences, but the explicit formula gives us different information about the sequences and makes it a lot easier to find specific numbers within a sequence. We need the same ingredients for the explicit formula as we need for the recursive formula. We specifically need our first term. We usually denote that A1, and we also still need our common difference or ratio. Today we're really going to only talk about the common difference because we're only doing arithmetic sequences or adding sequences today. We'll do geometric sequences tomorrow. So first things first, if we already know what our first term is, that's simply A1. To get to the next term of the sequence, or A2, sorry, I wrote that too big, we simply take A1 and add our common difference. Now to get to the term after that, the third term, we take our first term, the common difference from the second term, and we add one more of the common difference. To go to the next term, or the fourth term, we do the same. I'm going to go ahead and rewrite some of the information that we already have in a slightly different way. This is the same thing as A1 plus 2D. And this is going to be the same thing as A1 plus 3D. We're simply taking adding and turning it into multiplication. Let's take a wild guess on what A5 might be. I have a feeling if we were to write that out, you would end up with A1 plus 4 of our difference, or 4 times difference. So the formula for the explicit formula for an arithmetic sequence is going to be A sub n is equal to A1 plus D n minus 1, meaning we're going to keep going. We're going to add the difference each time, but we're only ever going to add it one less than the number that we're looking at. Let's go ahead and just try a few examples with this formula. If we have the sequence 36, 27, 18, 9, so on and so forth, we have all the information we need to write this with an explicit formula. First, we know that the difference between 36 and 27 is we're subtracting 9. 27 to 18, subtract 9 again, and so on and so forth. So we know that our common difference in this case is negative 9. We also know that the first term is the number right there, so it's 36. So therefore, the explicit formula for the sequence would be A sub n is equal to 36 plus negative 9 times n minus 1. If we were to say find the 10th number of the sequence, that's what we were looking for, we can simply replace 10 with n. Now from here, it's a pretty simple order of operations problem. 10 minus 1 in parentheses is 9, so then we have negative 9 times 9. So 36 minus 9 times 9 would be, which would be negative 45. So A10 is equal to negative 45. Similarly, we might end up with a problem that looks something like this. AN is equal to 7 plus n minus 1 multiplied by 200. Now, it's the exact same thing as what we had earlier. We're given the explicit formula. If we wanted to say find the 30th number of the sequence, then we would simply plug in 30 for n and solve. So we'd get 7 plus 30 minus 1 times 200. 30 minus 1 is 29 times 200. We've got to do the multiplication before the addition, according to the order of operations, which will give us 5,800. And our final answer will be 5,800 plus 7, giving us A of 30 is equal to 5,807. As always, let me know if you have additional questions.